In this video, we are going to expand our idea of factoring to now we're going to be solving quadratic equations using factoring. And in order to do that, we're going to use the zero product property. Well, in order to really understand the zero product property, we need to back up and talk about this just a second. So remember, the product is an answer to a multiplication problem. And so I have created a multiplication problem right here and set it equal to 0. So that's why it's called the zero product property. I have two things multiplied together, or I could have three or four, but I have some things multiplied together, and I have it set equal to 0. So in order for this equation to be true, think about what must be true. I have a number, and I've multiplied it by another number, and I'm getting 0 as the answer. Well, if I have 0 here, it doesn't matter what number I have here. I'm going to end up with 0 as the answer because 0 times anything is equal to 0. It's also true that if I put 0 here, doesn't matter what I put here, I'm still going to get equal 0 because something times 0 equals 0. I could also have 0 in both places because 0 times 0 is equal to 0. But if I have two numbers that are not 0, so let's suppose this number is not 0, and also this number is not 0. So 2 times 3, or negative 5 times 7, or 3 halves times negative 5 sevenths, it doesn't matter. If I have two numbers that are not equal to 0 and I multiply them together, my answer is not 0 either. So in order for the zero product property to give me an answer, either this number must have been 0, or this number must have been 0, or they both were 0. There's no other way to end up with a 0. So when I get my factors, remember factors are the things that multiply together to give you the expression that you had. When I get those factors, I'm going to be able to set each of them equal to 0 separately because I know that in order for my answer to have been 0, one of the things in the parentheses at least must have been 0. Okay, another thing I need you to notice about these problems, pay attention to the verb in the directions. Notice that our verb here is solve. Our verb is not factor. Factoring tells us how we're going to solve, but solve is your verb. So when I solve something, I end up with my variable equal to a number of some sort. So maybe the number is positive, maybe it's negative, maybe it's a fraction, but I'm going to end up with x equals a number, and that's how I'll know I'm done. That's when I have finished solving because I have a variable equal to a number. So here are our solving directions, and you can see those already written in your notes. Step 1 is always to look for the GCF. Now, we've been doing factoring long enough that y'all know sometimes there's going to be a GCF and sometimes there's not. So looking at number 1 here, I notice that there is not a GCF other than 1, and 1 doesn't do us any good to factor out. So we're finished with step 1. We looked for a GCF. Step 2 is to factor. Okay, so this is what we've already been working on. We know A is 1, B is negative 1, C is negative 2. So when I multiply A and C together, 1 times negative 2 is negative 2. Okay, so now you guys think for just a second. I need two numbers that will multiply to be negative 2 and add to be negative 1. What can we come up with? Negative 2 and positive 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So we've got our two numbers. Let's substitute those in. X squared minus 2x plus 1x minus 2. Still got that equals 0 over there. That's new, but we want to keep that with the problem. All right, cut it in half. This part is not new. This part is exactly like what we've been doing. Find the GCF of the left-hand side. All right, now look over here on the right-hand side because sometimes this confuses people. Sometimes people want to look at this and say, well, there's not a GCF. There's nothing that goes into both of those. But remember, you can always have a GCF of 1. So anytime you don't see anything other than 1, you're going to put a 1 right here. Now, I understand that 1 is understood to be in front of these parentheses, but I need that 1 so that I can do the next step. Okay, look in the parentheses. Right here, I have x minus 2. Right here, I chose to bring down that 1 that I had before because 1 divided by 1 is 1. And I have 1x minus 2. So are x minus 2 and 1x minus 2 the same? Yes, so I can factor that out. And in the other parentheses, I'll have x plus 1. So let me put that in there. Okay, so now we've done the factor part. Now we're ready to use the zero product property. Well, remember the zero product property says if I have two things multiplied together, then either this first one must have equaled 0, or this second one must have equaled 0 in order for me to get 0 as an answer. Remember we looked at that on the other screen. At least one of these must be equal to 0 so that I end up with a 0. So let me solve for x on this one, and I get x equals 2. And then let me solve for x on this one, and I get x equals -1. So I have two choices for x. Either x can be 2 or x can be -1. So let's check that. 2 squared is 4. 4 minus 2 is 2. 2 minus 2 is 0. Okay, so 2 checks out. -1 squared, -1 times -1 is +1. Now look here, we've got minus a -1. Minus a negative is the same thing as plus a positive. So I've got 1 plus 1, which is 2. Minus 2 is also 0. So both of those check out. I have two possibilities for x, either 2 or -1. Now the last part says write the zeros as ordered pairs. So the one that's a 2, that's going to be 2, 0, right? Because you can see that this would be in the f of x or the y spot. That's why my y value is going to be 0. And the other one is going to be -1, 0. Now that might seem strange. I'm just solving this equation. Why do I end up writing these as ordered pairs with an x and a y coordinate? Well, that's going to be really important for what's coming up. What you have just found are the x-intercepts. You see -1 and +2, which is exactly what we found earlier, -1 and +2. So when I have a quadratic written in this form, okay, first of all, look back in your notes. What form is this? Well, this is standard form. That's ax plus by plus c. I can rewrite that same function that was in standard form into factored form. X minus 2 times x plus 1 is the factored form of this same thing. If I were to FOIL this out, so I've got x squared plus x. Now multiply these. -2x minus 2. Combine like terms. And you see I end up with this. So the standard form, remember that tells us the y-intercept, and the factored form, that tells us the x-intercepts. So what we had to do before with our calculators, we had to plug this in on our calculator and find the intercepts, and we don't need to do that anymore. Now we can find the intercepts algebraically by factoring and then setting both of those factors equal to 0. And that's what we'll end up with. We'll end up with the x-intercepts, which is why when I had that -1 and that +2 for my answers, I put 0 for the y-coordinate because those are the x-intercepts. And you remember on the x-intercept, the y-coordinate is a 0. All right, let's do another one. Let's do this one. So this one automatically looks different because if you look back at that first one, it was equal to 0, and this one is equal to -2. So every time I solve a quadratic, the first thing I'm going to do is make that equal to 0. So 2x squared minus 5x plus 2 equals 0. So now it's in the correct form to do my steps. Okay, so first let's look for a GCF. 2, 5, and 2. Only thing that goes into those is 1. I look at my x's, x to the second, x to the first, no x. So they don't all have an x in common, so no GCF this time. We can skip that step. Okay, now let's factor. So identify your A, B, and C. All right, A times C, 2 times 2 is 4. Okay, so I want two numbers that multiply together to be 4 and add together to be -5. See what you guys can come up with. Hopefully you came up with -1 and -4 because -1 times -4 is +4. -1 plus -4 is -5. All right, so let's rewrite 2x squared minus 1x minus 4x plus 2. Still got that equal 0 there because our directions are going to say to solve by factoring. So I'm working on the factoring part, and then I will solve. All right, so I'll cut that in half, do the GCF of both sides. This one just has a GCF of x. And notice right here, when I factor out that x divided by x would be 1. So make sure you've got that 1 right here. Now on the right-hand side, look, I've got a negative and then a positive. I want a positive and then a negative. So what is it that I need to remember to factor out? My GCF is going to be negative 2 because I need to change the signs on both of those. So negative 4 divided by negative 2 is positive 2. Positive 2 divided by negative 2 is negative 1. Still got that equal 0. All right, x minus 2 and 2x minus 1 are my two parentheses. So you can see I did that backwards than I did last time, but it doesn't matter. Commutative property says it doesn't matter what order you put your factors in. Okay, so I factored it. I did that one. Now I'm ready for the zero product property because I have two things multiplied together to be 0. Well, that means either this first one must have equaled 0 or this second one must have equaled 0. So I'm going to add 2 to both sides on this one. X equals 2. And I'm going to add 1 to both sides on this one. So 2x equals 1. Dividing by 2, I get x equals 1/2. All right, I did the zero product property. And now I'm going to write these as ordered pairs. So 2, 0, right? Because remember my y value right there is a 0. And on this one, 1/2, 0. Okay, so let's see what we have found here. You can see that I have crossing the x-axis right here. 0.5 is the same thing as 1/2. And right here at positive 2. So when my original function was in standard form, only when it's in standard form is this last one equal to the y-intercept, which you can see right there. Now if I take this same one and I write this standard form into quadratic form, well, that's going to be what I just figured out. X minus 2 times 2x minus 1. So factored form is what gives us the x-intercepts. Standard form is what helps us easily find the y-intercept. Okay, we're going to finish this together in class tomorrow. I just thought it would be helpful if you guys had a little bit of an advance on what we're doing so that we can dig into this and really talk about some of what this means. We'll finish out lesson 8 notes in class.